This video is to help you fill out the Quest study guide. On the first page, you'll see a list of key concepts that will show up on the Quest, and then starting on the next page, you'll see some key vocabulary words as well as a space to write examples for each. I'm not going to go through the key vocabulary in this video, however, I do recommend using your textbook, using your notes, using other resources to fill out this vocabulary, and then using it as a guideline to create your key fact sheet or your cheat sheet that you'll be able to use on the upcoming assessment. So this video is mainly going to focus on kind of the 4 key concepts that I picked out from this unit so far. So the first key concept that's going to show up on your Quest is how to use the unit circle to solve for cosine and sine of angles in degrees and radians. So let's just do a bunch of example problems of how to use the unit circle. So the first, we'll do something simple like the sine of 330 degrees and see kind of where on the unit circle to find that information. Then we'll try something a little bit more difficult, like finding the sine of an angle larger than 360. Like let's try to find the sine of 540 degrees and think about how to do that. Then we will try a negative angle. So say you're asked to find the cosine of like negative 45 degrees. We'll go over that. And then we'll do 2 examples of radians. So we'll try like sine of 3 pi over 4. And then we'll try cosine of negative pi over 2. So this kind of covers the gamut of all the different types of cosine and sine questions you'll be asked to evaluate. So for this, you will definitely need your unit circle. And if you need a copy of a fully filled out unit circle, just let me know. I have a bunch of extra copies of this if you're looking for like a fully filled out one. So the first question is asking for the sine of 330. The first thing I'm going to do is locate the angle in question, which is 330. 330 is like the last angle right before 360. I can see some pieces of information on the unit circle like, oh, okay, my angle in radians is 11 pi over 6. Remember, the thing is 330, but they both refer to the same place on the circle or the same angle. And then I can see I have this coordinate, and this coordinate is not just kind of random numbers. This coordinate tells me some really important and specific information about this particular point on the circle. The 0.86, the meaning of that, the importance of that is it is the cosine of the angle. It is the cosine of 330. And the meaning and significance of negative 0.5, it's the sine of that angle. So really important information contained in this point. Both the cosine and the sine of my angle live here. So I'd say kind of the key thing to remember, and this is probably for like half of the Quest, this is the key fact. For any point on the unit circle P, the coordinates x comma y, the ordered pair, the x value corresponds to the cosine of whatever angle is in question, and the y coordinate corresponds to the sine of whatever angle is in question. If you remember that, it's going to make your life a lot easier. X value cosine, y value sine. So because I'm looking for the sine of 330, I'm going to pay attention to only the y value here, because the sine is corresponding to the y value. So I can kind of block out all the other information. I just care about this negative 0.5. So the sine of 330 corresponds to the y value at that point, which is negative 0.5. Now let's make it a little bit more complicated. What if I was looking for the sine of an angle larger than 360, like the sine of 540? Kind of a trick here, and we can write this off to the side, is if you ever have an angle larger than 360, you can always just subtract 360 to find a corresponding angle that is within the unit circle. So let's try that. Let's subtract 360. 540 minus 360 is going to give me 180. So I know that the sine of 540 is going to be the same thing as the sine of 180. Another way to think of this is to get to the angle of 540, we start at 0, we do a full 360 rotation, right? And then we do another 180, an additional 180. So we can think, okay, 360 plus an additional 180 degrees of rotation is going to give us our angle that we're looking at, which is 540 degrees. So 540 degrees is going to fall in the same exact place as 180. It's just 360 degrees away, so it falls in the same place on the unit circle. The radian measure is pi. The cosine is -1 and the sine is 0, and it looks like I was looking for the sine in this particular problem. So the sine of 540 degrees is equal to 0. The same thing as the sine of 180. All right, next would be a negative angle. Things to remember for negative angles is that in geometry it's not possible to have a negative angle. In pre-calculus it is possible because we know negative angles are just rotating the other direction on the unit circle. So normally on the unit circle we rotate up or counterclockwise. For a negative angle we rotate down or clockwise. So putting that in my own words, I'm just going to say negative angles rotate in the opposite direction. So if I start in my same starting position and I'm rotating negatively on the unit circle, so down by 45 degrees, negative 45 degrees is going to end up directly reflected across the x-axis from positive 45 degrees. So this is positive 45, this is negative 45, and negative 45 degrees is in the same place as positive 315. And the cosine value at that point is 0.71, the sine value is negative 0.71. So the cosine would be positive 0.71. All right, and then a radian measure. I'd say the first thing to do when you see something with a radian, a trigonometric function with a radian, is just realize that you can convert to degrees. So I can convert this to degrees using my equation to convert radians into degrees, which is 180 divided by pi. So maybe just make a note here, it would be 180 over pi would be the conversion factor. I actually don't have to do that because I already have this information on my unit circle. So I'm going to go to 3 pi over 4. I can see that corresponds to 135 and that negative. Oh, and I was looking for the sine, so I want to look at that positive 0.71. Sine is positive in the second quadrant. And then for cosine of negative pi over 2, it's a negative radian. Negative pi over 2 is the same thing as negative 90 degrees. So I see on my unit circle pi over 2 corresponds to 90. So negative pi over 2 corresponds to negative 90. Negative 90 puts me at the bottom of the unit circle with a sine value of -1 and a cosine value of 0. So let's just write in here so we don't get confused. The sine of 3 pi over 4, that was the same thing as the sine of 135, and cosine of negative pi over 2 is the same thing as the cosine of negative 45. All right, so that is a huge key part of this quest, is just being able to find information on the unit circle and know what it all means. Definitely keep trying these practice problems. There's a bunch on Delta Math for this type, and there's also a lot on the practice quest that you can go through and redo those problems, as well as problem set 7.1 would be a good place to find problems similar to this. So that's problem set 7.1, Delta Math, or the practice quest. Okay, so next is key concept number 2. Key features of the sine and cosine graph. We're actually just going to graph sine and cosine. Sine and cosine never go above +1 or below -1. And we're going to label the x-axis as 90, 180, 270, 360 degrees. We'll start with the sine function. The sine function comes directly from the unit circle. So at 0 degrees of rotation, the value of sine is the y-coordinate, which is 0. So 0 degrees of rotation has a sine value of 0. Therefore, the first point of sine is at 0. 90 degrees of rotation, sine goes up to +1. And then we can make our way around the unit circle just doing the same thing. So 180, sine is back to 0. 270, -1, 360, 0. So we're going to end up with our sine function that looks like this. Key thing to notice about the sine function, the thing that distinguishes it from cosine, is it goes through the origin. It goes through the point 0, 0. That's how you can tell that something's a sine function. It also always starts by increasing. So it starts at 0 and it starts by increasing towards 1, which you can see is true on the unit circle. Sine starts at 0 and it starts to increase to reach the sine value of 1 at the top of the circle. Next up is cosine. Cosine, as we can see on the unit circle, starts at the value of 1. At 90 degrees, it goes to 0. 180, it goes to -1. 270, back to 0. And 360, you end up where you started at +1. So the cosine function looks like this. And it goes through the point 0, 1. And that's for the cosine function. All right, the last key thing to know about these two functions, sine and cosine, is they both have the same amplitude, period, and midline. So let's go through and quickly identify the amp, period, and midline of these two functions. For both of them, they have a midline at 0. Again, maximum is 1, minimum is -1, therefore the halfway point or the midline would be 0, halfway between +1 and -1. So the midline is at y equals 0. Because the midline is a horizontal line, we always write it in the form of y equals something. The period for the sine and cosine function is always going to be 360 degrees because that's the number of degrees in a full rotation of the unit circle. The period can also be written as 2 pi if you graph in radians. So either one of those answers is true, 360 or 2 pi. They're both a full rotation around the circle. Amplitude, the distance between midline and maximum. You can see on the function between the midline and the maximum there's an amplitude of 1. You could also think of the amplitude as the radius of the circle. In this case it's the unit circle. The radius is 1, therefore the amplitude is also going to be 1. Alright, I'm going to pause the video here. I will make a part 2 to go over the next 2 key concepts.